Ladies and gentlemen, welcome to my session, SSD the Magic Bullet. I'm Christian Huebner. I work as a storage architect at Mirantis, and in my daily work, SSD is playing a bigger and bigger role. Customers are transitioning from small installations with hardware that was lying around to large installations that have multiple storage technologies built in. Let's jump right into it. So, first of all, the transition from from spinning storage to SSD is not quite as straightforward as it originally appears. Of course, the reasoning behind it, everyone knows SSDs are fast, SSDs are reliable, they are not influenced by shock or anything. But there are a whole bunch of technological decisions to be made when inserting SSDs into your storage environment, and I would like to talk to you about this today. First of all, SSD can be used in a number of different ways in OpenStack, and I'm going to touch on a number of those from a point of view of an architect going to customer sites and analyzing performance needs and the solutions that we can put in place to make those performance needs available. And finally, we have caveats and architectural advice. This is what you can do to make the transition more smooth than it is. First of all, anyone remember this old 5 megabyte drive that I found, and I thought the picture was rather appropriate. But today's hard disk actually still have largely the same problems as those old behemoths. One of them being that the mechanical pieces are not able to produce access to the data as fast as on-chip memory can do. So if you want to access something on a spinning disk, you have to position the head, you have to wait until the sector comes around, and then you can get your data. And this, of course, takes milliseconds, 10 milliseconds, 20 milliseconds. And this is also, of course, if you have data spread on your hard disk and you have access multiple small files, then the head has to reposition every time. So you get only a very limited performance number out of that. SSDs get around all this by being addressable like memory. Of course, you still have, other than in system memory, you are not directly connected to the memory controller on the system. You are connected to either a SAS controller, SAS host bus adapter, SATA controller, or in newer PCIe and NVMe sets, you are connected to the North Bridge. Technological considerations, of course, there are 3 types of commonly used hard disks. First is high write. They are for 10 to 25 times the capacity per day write for 5 years. Mixed use for 1 to 5 times capacity per day, and read optimized for 1/10 to 1 times capacity a day. One thing that I have seen time and again is that people are trying to use consumer drives in enterprise environments, and I would highly advise against that. We have not had a situation where this has happened and where it has not ended in very negative outcome. So it is, in some situations, it is even important to use, for instance, high write disks, and I'm going to touch on that later. But remember, when building bill of materials, if you have consumer drives lying around, put them somewhere else. So what happens if a device dies? Yes, SSDs have limited lifetime, and the limited lifetime is usually caused by the flash memory boundaries weakening, softening, and losing it, and the flash cell losing electrons. Theoretically, the drive should still be readable at this point, and you should be able to get the data that's on the drive off, but I would not rely on that. So having Plan B is a useful thing to have. And you will, of course, have no write access once the device dies. Bus types, we already had that. SATA is slow and cheap. personally, I'm not a big fan of it. It's barely cheaper than SAS bus, and it is definitely slower in enterprise applications. And then we have modern PCI Express and NVMe SSDs. They used to be something that you would have to actually physically put into the server, not plug it into the front of the server. Nowadays, you can actually get hot plug versions of that. I went by the Dell booth yesterday, and they showed me one of the newer R630s that have 4 NVMe slots right up front, so you can basically use them as you would use regular SSDs. And NVMe drives are faster by a factor somewhere between 5 and 50, so they can replace multiple SAS drives. So how do we use SSD in OpenStack? First of all, of course, Ceph is in most people's vocabulary when you're talking OpenStack. And one thing that in Ceph is consuming a lot of time and slowing down your access, specifically write access, is that Ceph journals onto the spinning drives by default. So you have not only your write access, but you also have, in addition to the write access, you have to have the journal write access and then the journal delete access when the journal is finished with. So you have multiple steps instead of one step. And so having an SSD instead as a journaling device helps. But in high write situations, this is a place where you absolutely have to have the high write SSDs to make sure that you will not have devices die prematurely on you. Of course, in Ceph you can recover from that journal, but it is an effort, and it is usually means that you are rebuilding the OSD, or Ceph is rebuilding the OSD, which causes additional traffic. And there's a rather interesting article, a rather interesting blog article that I ran across a couple of weeks ago about journaling performance of Ceph with different types of SSDs. And there is, even between the SSDs, there are even between high write SSDs, there are pretty big performance differences. So it makes sense to research and test before you actually put that into production. And finally, an SSD can be shared between multiple OSDs. For instance, you would have a system with 16 OSDs, and you would have, let's say, 4 SSDs that are shared between these 16 OSDs. If you have NVMe disks, as they are drastically faster, you can actually have more OSDs per SSD. But the risk that you're running with that is if you put too many OSDs behind an NVMe journal, is that when the NVMe journal dies, you have to rebuild more OSDs. So keep that in mind when you're deploying that. There's also the possibility of building a cache tier in Ceph. Unfortunately, in Firefly, the performance is rather lackluster. In Hammer, it is improved. It's still not perfect. I think that Inktank is actually going to tell you the same thing, but it is drastically faster than spinning storage. So we have done performance testing with a cache tier, and we found one thing, that you want to have multiple OSDs sharing one SSD, because the threading model of the OSD code is not perfect, and you're getting a lot less from tuning the number of threads per OSD than you get from building more OSDs and putting multiple OSDs onto one device. And in a cache tier, you are going to be most likely CPU bound, so plan and budget for high performance CPUs. In Swift, there is little reason to put a ton of SSDs in there. The one thing that I would use them for is the account and especially container databases. As you probably know, the account and container databases are a very large number of very small files, and the access to those, if they are interspersed with the data on the actual spinning disks, is bottleneck, and it's going to slow down your container access significantly, especially the write access, because every time you have to or you're writing something into a Swift cluster, you will also have to write to that container database, to that small file, so you will lose performance. And putting those onto an SSD is definitely a useful thing to do. Commercial products, of course, you're probably familiar with SolidFire. They have a big booth. There is NetApp EMC. They all have their devices, and they all have drivers for OpenStack Cinder, and they make it. Everyone says we have the best one. I currently cannot give you the one that you should buy. Finally, localized drives on compute nodes. Instead of spinning disks, you can use SSDs, but this is only really useful if you have a lot of traffic spinning up and spinning down instances. What's the verdict? SSDs provide a big value when you're using them in the right environment and with the right, not only intentions in mind, but with the right design. And before you splurge on SSDs, consider the business cases. Is the speed really necessary, or are you going to use it in a proper way? Finally, do not cheap out. Do not buy cheap drives in for high write situations. This is going to end badly. And just as a last point, we have reviewed a lot of customer bill of materials, still are doing that with every customer that we engage with. If you have any requirements there, we would love to help you out with this. Finally, 2 examples. One customer built 50 compute nodes with 2 NVMe devices per compute node just in case. Is that a useful way to spend your money? Probably not. But in my opinion, you would buy a lot more compute nodes, or should buy a lot more compute nodes instead of building the expensive SSDs in there. And then as a very last point, read optimized drives in high traffic journaling situation. A lot of the drives that you get at Dell or at Supermicro will not tell you these are actually read optimized drives, meaning the least resilient variety. So you should look up what the number really means, go to the manufacturer and see whether this is actually a high write disk. Thank you very much. I hope that I have enlightened you a little bit about SSD and that I have contributed a little bit to your success in the storage environment. If you would like to email me or tweet to me, here are my contact details. I'll stay outside for a few minutes so we can, if you have questions, we can treat them outside. Thank you very much.